Okay, so this example is really divided in two parts. We are asked to calculate the work done against gravity and the work done against friction by this block which is being dragged up the slope. So I'm going to answer the questions in the same order as the question really says. So let's go for part one, which is to calculate the work done against gravity. Okay. Now the formula for work done against gravity is basically going to be just force times distance. I mean, it's the same thing, right? So mg delta h. Now again, just as a side note, this formula is actually exactly the same formula as gravitational potential energy, and it's not a coincidence. It's because the work done against gravity is really the energy stored by this block being raised. Okay, so I know what m is. M is given as 3 kilograms. So 3 times 9.8. Now I just need to calculate what the change in height is. Now the change in height is basically going to be this here. The hypotenuse of this triangle is 10 meters, which means I can calculate delta H. Let me just find my calculator. So delta H can be calculated using trigonometry, right? So it's going to be 10 sine 40. So make sure your calculator is set to degrees. Okay, so delta H is going to be 6.43. I've rounded to two decimal places. And then to basically complete this part, just times that by 3 and times that by 9.8, which gives me 188.98 joules. Okay, so I'm going to round that up to one decimal place, which is going to be 189 joules. Okay, for part B. Let's just see if I can tidy this. There we go. That's a bit clearer, isn't it? Right. So for part B, or part two, I should say. So this one's going to be a little bit more complicated because the formula for work done against friction, or indeed any force other than gravity, really, is that the work done is equal to force times distance. Well, I know what the distance is. The distance is going to be 10 meters. Okay, so I just need to calculate what the force is. Now the force in turn is calculated by F is equal to mu times the reaction force. Okay, so again, I know what mu is, so that's going to be nice and easy as well. That's 0.4. Okay, so really I just need to calculate what R is. Now think about what's happening here with R. Let me just get my lovely Finding Nemo ruler. So what have we got? We've got, I'm going to just make this angle a little bit more, look a little bit more steeper. Why is this not working? Okay, so there's my slope. There's my block. Obviously gravity is pulling vertically down. And we have the normal reaction, which is this here. Okay. Now this, even though my arrows are grossly unequal, is actually going to be equal and opposite to this. Okay, so really, I need to calculate what this is. Okay, so this force here, the hypotenuse of this, is going to be 3g. I know that this angle here is 40 degrees. This is going to be a right angle. Right, okay, so and that's also a right angle. Okay, so so if this is 40 degrees, then it means I can calculate what. Why did I draw it like that? Okay, let me try it this way. So 40 degrees, 40 degrees. So this one's 40, which means that this one must be 60. 60? What am I saying? 50. Right? Now if that one's 50, then that one's 50. That one's going to be. This one here is going to be 40 degrees. Okay? Which kind of makes sense if you think about it. All right. So to calculate this here, it's actually going to be 3g cos 40. Okay, so that will be the normal reaction. Okay, so 3 times 9.8 times cos 40, which will give me 22.5. Now the unit for this is going to be newtons. Okay, perfect. Right, so now I've got that, I can put this back into this equation here. So I know that the force, multiplied by 0.4, which is going to be exactly, pretty much exactly, 9 newtons. Okay. Now, the unit hasn't changed because the coefficient of friction is a dimensionless scalar. Okay, it's just a way of dealing with proportion, really. All right. So now I've calculated the force due to friction. All I need to do is multiply that by the distance. So 90 joules. And there we have finished.